Welcome back. Today we're going to talk about definite integrals, section 2 of chapter 4. Let's start with the definition. We already talked about approximation of the area under the curve. So here, a definite integral of a function f over an interval a to b, from a to b is the same as thinking about it as an over interval, is defined in this way. The integral, this curve, this big S is called the integral. Integral from a to b, from lower to the upper, is kind of the interval of the function f dx. These are notation. F of x dx. Dx is the notation that we write. It's not the derivative yet. It's just a notation. So later on we will mention that means this is the given derivative of a bigger function. So the integral from a to b of f of x dx is written in this format. It means it's going to be equal to the limit n approaches to infinity of this sigma is the summation of f of xi delta x. I don't want to get into this notation, but this is what we already say. It's if you add up all those rectangles that we talked about last time. If you add up all those rectangles, you approximate an area. The more number of rectangles do you have, the better the approximation is. If you took a limit by letting all those areas to be smaller and smaller as by picking n to be larger and larger, then you have an accurate area. So instead of using that summation notation, we can represent it by this integral form. So the definite integral is basically the area under the curve f, not approximated, but the exact area under the curve f, divided by that integral notation. And we assume that the curve is above the x-axis to have a positive area. If the curve is underneath the x-axis, you still mention that the area is positive, but this integral would be a negative number. So what does it mean? That means if I have this curve f and I want to calculate the area under the curve, I can say the area is basically integral from a to b of f of x dx. This is the same as that area. But here, since I have the curve to go above and below the x in the next example, in this second graph, you will have up to this point, let's call it C. Here, let's call this point D. From A to C, this area is above the x-axis. So if you write the integral from A to C of f of x dx, then this is exactly this highlighted section, this shaded area. On the other side, from C to D, integral from C to D of f of x dx, it's not the area exactly, it is negative the area, because it's below the x-axis. So this part becomes negative. And the next one again is above the x-axis. So if you write integral d to b of f of x dx, this means yes, it is the area from d to b. It's the area under the curve in the positive section. So if the curve is above the x-axis, the integral becomes positive. If the curve is below the x-axis, then the integral becomes negative. So this definite integral is just representing the area exactly if it's above. If it's below, it's just by a negative sign. At the moment, it's just a notation, but later on we will say it calculates something. We can calculate something with this definite integral. So here is an example. It says, use geometry or evaluate the integrals by interpreting in terms of area. So first, what does it mean? It says integral from -1 to 2. So over the interval -1 to 2, this is the interval given. We're going to find out, this is the f function, f of x dx. So what is the function f? F of x is given absolute value of x minus 1. So what do you want to find is the area under the curve from f of x from absolute value of x minus 1. So the area over the interval -1 to 2. So if I draw the absolute value of x minus 1. Let me draw this. Maybe I should have drawn it a bit higher. Absolute value of x was this 45-degree angle line. Minus 1, it means shifted down 1 unit. Those transformation now, you notice it's very useful for graphing faster. So from -1 to 1, here's from -1 to 2. Sorry, here's 2. Corresponding y values could be calculated by replacing the number into the function. So if you replace 2 into the function f, what do you get? It's absolute value 2 minus 1, which is simply 1. If you replace 0, this is -1. If you replace 1, you'll get 0. So what we want is, let me erase the part that I don't really want. Here's segment, erase this part. What we care about at the moment is finding the area under the curve in this section, as well as the area in this section from -1 to 2. And then we want to add these two areas together. That would be the integral from -1 to 2 of the function f dx. That's what this integral represents. This is definite integral. So how do we do that? First shape, I'm going to draw each shape separately. This triangle, and sorry, an isosceles triangle, so kind of should look like that. These two sides should be equal. My graphing is not good. And then you have the other triangle. How do you find the area in a triangle? It should be height times length or whatever that's called. H, one is r, doesn't really matter. So this is 1, and here's you have 2. And in the other one you have 1 and 1. So you can calculate the area of each one. What's the area of the first one? Area would be 1 times 2, sorry, 1/2 times length times height, or times 1 times 2. And in the next one, area would be 1/2 times 1 times 1. It's half of a square or half of a rectangle. That's how you get that extra 1/2 in. So the first area would be 1/2 times 1 times 2, which is simply 1. So this area is here is 1. The next one is 1/2. This is 1/2. So what is the integral? Remember, the integral in the section below is negative, so I should have -1 plus the section above is positive, 1/2. And if you add them up, you get -1/2. So this integral is simply -1/2. That's what it calculates. It gives you the area of the positive section plus the area of the negative section. If you add those two together, you'll get -1/2. Okay, so this is using integral by interpolating. Not always is that easy. Let me shift this up a bit. Sometimes you should figure out what the function basically looks like. So in here, you're given this example from -2 to +2 of square root of 4 minus x squared. So the interval is given -2 to +2, and the function f is given square root of 4 minus x squared. Function f is not simple to see, but if you haven't seen this kind of function, you can pick points to approximate, but this is basically the upper half of a circle. So from -2 to +2, if you replace 2 and -2 into the function, what you get is 0, both. If you replace 0 into the function, you'll get 2. So you'll get, if you pick more points, you'll see this curve as the square root of 4 minus x squared. You can call this y. Maybe I should mention this in case you have questions about it. So here, let me call this y. You have y equals 4 minus x squared, square root of that. If you square both sides, what you get is this squared, that squared. square root will cancel out. Move the x squared to the other side, you'll get x squared plus y squared equals 4. And this is basically a representation of the area of a circle, the equation of a circle. Let's not get into it, but in case if you're wondering, that's why it's the upper half of the circle. If it was negative here, then it would be the lower half of the circle. So what does it mean? This integral means find this area. That's it. If you understand how to graph the function, and if you understand the question, simply they ask you to find the area of the half of a circle. What is the area of the half of a circle? It's pi r squared is the area of the circle, but half of it would be 1/2 times pi r squared. So it would be 1/2 times pi times radius, in this case is 2 squared. Simply 2 pi. So this integral is 2 pi. Calculating this integral, it's kind of not that easy. It would be one of the topics that we would talk about at the end of chapter 4 or 5. But you notice that by just drawing the curve, you can answer this question simply and say this 2 pi. Okay, so this is using the curve and specific graphing to explain what the area is. There are some properties for the definite integral. By the way, definite integral means there is always this upper and lower half. It means you're calculating a number, you're figuring out what is a number. Later on, we will have indefinite integral, which means you do not have these upper and lower values. So one thing that you should notice, there are some properties about the definite integral. One is, if you interchange the boundaries, if I ask you integral from 1 to 3 of f of x dx, and compare that to 3 to 1 f of x dx, this may not make sense at the moment, but these two are opposite. If you get 5 here for this one, the other one must be -5. This is a consequence of adding areas from direction. So you're moving left to right or right to left, it kind of makes a difference. Okay, so if you change the boundaries, you have to multiply a negative times the function. What if it's from a to a? What does it mean? It means if you have a function f, I erase this part. If you have a function f, and they ask you to calculate the area from a to a. A is not here anymore. A is exactly at that point. What is this area? This is a straight line. It has 0 area. So what is the integral? The integral must be 0. If the boundaries are equal, then the area is 0, because the interval is basically a point. What if you have a constant function? So if I have a constant function, what is the area? So this is the constant function f. So let's assume you have a constant function, point C. From A to B, what is that area? Is this height times this length, because it's a rectangle. The height is C, the length is B minus A. So C times B minus A. That would be the area. So the integral from A to B of any constant dx is C times B minus A. This dx is just a representation of the variable. In this case, there is no variable since it's a fixed constant function. There are some properties that if you have two functions added or subtracted from each other, you can split the areas. So let's say you have two functions combined above each other. And if you add these two functions together, you will get a larger function. What you can do is calculate the area of the first one, area of the second one, and add them up. That kind of tells you the area of the bigger function. Or you can find the sum of the two first, and then find the area. That's what we're talking about. That if you have two functions added together inside, you can calculate the area of each one separately and then add them. Or you can add the two curves together and then calculate the area. It's exactly the same thing. You can break it up. And here is one of the most important properties of this definite integral is, what if you break down the interval? Let's say you have a function f, and from a to b, from B to C. If I ask you to calculate for area A to B, you should say this is the integral from A to B of f. And from B to C, this part would be from B to C of f. So together, if I add them up, what do I get? I get the whole interval from A to C. I can ignore the middle point f of x dx. So this means if you have A to B plus B to C, basically of the same function. Notice that it should be the same function. You cannot have different functions added together and calculate the area. If that's the case, you simply can just add these two intervals together and combine them together and calculate the area over the whole interval. And one thing that is I forgot to mention is if you multiply a constant to a function, you're just rescaling that function. So if you have a constant multiplied by a function, you can calculate the area without the constant and then multiply that constant later. So it means if you have kind of like this function and multiply by 2, you're just rescaling this to 2 of them or something like that. So you rescale. You can calculate this area, then multiply by 2 later. Okay, here's an example of using these properties. So let's say given this information, given the area from 0 to 1 of this x squared function dx is 1/3, area on the curve x over the interval 0 to 1 is 1/2. From 0 to 2, x squared is given 8/3. From 1 to 2 of x dx is given 3/2. Given all these, they ask you to find the area from 0 to 1. Maybe first let's do the second part. It's easier. Yeah, I should have picked maybe a simpler example at the beginning. This way we would have had. Okay, let me move this to later. We will discuss this. Actually, let's discuss it because it has all the elements in it, so I can break it up. So let's look at this. First, you have, maybe use a bracket. First, you have 3 functions. One is 2x squared, the other one is x, then you have a constant 3. If you have a sum of 3 functions, you can break this up into 0 to 1, 2x squared dx, plus, actually in this case, minus 0 to 1 x dx, plus 0 to 1 3 dx. So you can break this integral into 3 functions, since these are addition or subtraction of 3 functions. And what do we know? We know from 0 to 1 the integral of x squared dx. What if you have a 2 in front? You can move that 2 outside and calculate later. Multiply or rescale it later. So what is given is 2 times, let me keep this 2 times the integral from 0 to 1 x squared dx is given 1/3. 1/3 minus from 0 to 1 x dx, integral is given as 1/2, so minus 1/2. Plus, what is the integral from 0 to 1 3 dx? It's not given, but 3 is a constant function. And one of the properties that I mentioned was that if you have a constant function, the integral over the interval a to b would be c times b minus a. So in this case would be 3 times, it's a rectangle, 1 minus 0. Top minus bottom here, 0. Okay, so 2/3 minus 1/2 plus 3. If you add these numbers, you'll get 1/6. 3 plus 1, 6. 3 times 6 is 18, 19/3. So this would be this integral, definite integral from 0 to 1. What if they ask you to calculate the integral from 1 to 2 of 3x squared? What you have is, if you look at both of these two, the one corresponding to x squared dx. What you have is from 0 to 1 and from 0 to 2. What do they want is from 1 to 2. So what is the integral of 1 to 2 3x squared dx? Is saying that calculate from 0 to 2 of 3x squared dx. Take away the part that is from 0 to 1 x squared dx, 3x squared dx. right? It's the same as saying if you want to calculate the integral over the interval 0 to 2, what you can do is break it up to, let's say this is the function f. You can break it up to 0 to 1 and then 1 to 2. You want to find out this part, the integral from 1 to 2. So you can calculate the whole area, then take away this area, this 0 to 1 part. That's what we're trying to do. This is one of the properties that I mentioned that is very important. And now we already know some of these. This is the same as 3 times the integral. The constant doesn't really matter. You can multiply it later. 3x squared dx minus 0 to 1. Sorry, 3x squared dx. So 3 times integral 0 to 2 of x squared dx is given 8/3. 8 over 3 plus minus 3 times integral 0 to 1 x squared dx is given 1/3. So you get 8 minus 1, this becomes simply 7. So we calculated the integral of the function 3x squared over the interval 1 to 2. So this is the area under that curve. Is exactly 7 if the other two informations are accurate. Okay, so this is how to use these properties. I don't want to get too much into detail for these. You can skip over steps. You do not always need to bring out these constants and multiply it later. Oh, by the way, if they ask you to calculate area of 2 to 1 3x squared dx, what would be the answer? You find 1 to 2 first. Remember, these numbers, if you interchange them, it would be opposite at the end result. This would be the same as minus 1 to 2 3x squared dx. We find the 1 to 2 3x squared dx integral, then you multiply negative, so -7. That's important to note. Oh, there's another type of question that they ask very often, is based on the graphing. This shows up often. So if they break out the area under the curves into 3 sections, for example, A, B, and C, then they ask you to, given the area in each section, the area of A is given, area of B is given, area of C is given. You notice the areas are always positive. Area is negative, never negative, but the definite integral could be negative. If the area is below the curve, then the definite integral is negative. So in this case, what if they ask you to find first part, 1, let's say. If they ask you part A, to answer integral from 0 to c of f of x dx. So where is 0 to c? Here is 0, the origin, to c. Means find the total area under the curve. So it would be area of A minus area of B plus area of C. Since A is positive, C is positive, and B is below the x-axis, should be negative. So you get 1 minus 2 plus 3/4, which ends up to be negative 1/4. The total area will turn out to be negative. How about part B? From A to C, C to A of f of x dx. From C to A, it says from here to A. If you notice that you're going backward, you're given in the opposite order. So first, rearrange it from A to C of f of x dx. If I do that, I should multiply negative. What is the area from A to C? It should be negative B plus C. But there was a negative outside. Do not forget that negative. It would be B minus C. You could have done this by just going backward and say negative negative becomes positive. So B minus C is 2 minus 3/4, which is 5/4. And what is the area from B to B of f of x dx? From B to B is only at that location. Area at this point is 0. It's not about the fact that it's B. It's just since these two match up, the area must be 0. It doesn't really matter what the function is. If there is no interval, if it's only at one point, the area must be 0. Okay, this is the end of 4.2 as well. And next time we're gonna start a new section. Hopefully we will get more into detail of what is this integral basically represent? How do we calculate exactly without having the curves, without having all those data? So I'm going to stop at this point.